Hey, welcome back to our notes for rational functions, and in the first video we completed step number 1, which was to find the wholes of the rational functions, if any. And in example A there was a hole at -2, 8/5, and in example B the hole was located at 3, 0. Now recall that we're going to follow these problems A and B through all the steps in graphing rational functions. So now we're going to take this example A, 2x squared minus 8 divided by the quantity x squared minus x minus 6, and we're going to continue now with that problem here with steps 2 through 4. And steps 2 through 4 on the front are to find the vertical asymptote, to find any zeros, and to find the y-intercept if those exist. So in problem A, right, we have our original form, then we factored it completely and canceled the x plus 2. That created a hole in the graph. And then the completely simplified form is 2 times the quantity x minus 2 over x minus 3, or if you distribute that 2, you end up with 2x minus 4 over x minus 3. So step number 1 here is to set any non-canceled factors in the denominator equal to 0 to find vertical asymptotes. And it's the non-canceled factors in the denominator part there that's really important to look for, because the canceled factors, those formed a hole in the graph. So now to find the vertical asymptote, we take the denominator, which is an x minus 3, and we set that non-canceled factor equal to 0 and solve for x. So we add 3 to both sides, and x equals 3 is our vertical asymptote. Okay, then to find any zeros, step 2 is to set non-canceled factors in the numerator this time, right? So still non-canceled factors, but now we're looking at the numerator of that rational function simplified form. We're going to set that equal to 0 to find any zeros. So our numerator is 2x minus 4, and then we're going to add 4 to both sides, and 2x equals 4. Divide through by 2, and x equals positive 2. So that means that the coordinate of the 0 is going to be at 2, 0. Okay, that'll be our x-intercept. Okay, then to find the y-intercept in step number 3, we're told to substitute 0 for x and solve for y. Okay, so we're going to substitute 0 in here for x, 2 times 0 minus 4, and then 0 for x in the denominator is a 0 minus 3, and that's negative 4 over negative 3, which is positive 4/3. So the y-intercept is at 0, 4/3. Okay, so now we're going to try that in example B. Okay, and the vertical asymptote, we're going to look at the denominator of our simplified form and set that denominator, that non-canceled factor, equal to 0. So we have x plus 3 equals 0. We'll subtract 3 from both sides, and x equals negative 3 is the vertical asymptote. Okay, then to find the zeros, or the x-intercepts on this graph, we're going to set our non-canceled factors in the numerator equal to 0. And since I already have my completely factored form, rather than using standard form for that numerator and having to factor again, I'll just go ahead and start with that factored form. So x plus 4 times x minus 3, that's set equal to 0, and since it's factored, I set each factor equal to 0. So x equals -4 and x equals +3. So I have zeros on my graph at the point -4, 0, and at the point 3, 0. So 2 x-intercepts on this graph. And then the y-intercept we find by putting 0 in, substitute 0 for all the x's, and then solving for y. So we're going to put in a 0 for x, so 0 squared, plus, and then put in 0 for x, and then -12, divided by, substitute a 0 for x, and then add 3. So we've got a -12/3, which is -4. So our y-intercept is at 0, -4. Okay, so another thing that we want to look at is, remember, we're continuing the same problem through. So in example B, 3, 0 was a hole on this graph. And now in example B for steps 2 through 4, we found that 3, 0 was a 0 on the graph, an x-intercept. We can't have an x-intercept existing where the graph is undefined, and a hole is a point where the function is undefined. So because of that, we're going to cross off 3, 0 from our list of x-intercepts, because an x-intercept cannot exist where there's already a hole in the graph.